So, welcome back all. In this session, I'm going to discuss the concept of normal form, which do have many real life application in the decision making, like in digital circuit, automated traffic control, computer algorithm, where we often need a logic that is clear and structured in a simplified manner. That means in place of simplifying the complete expression, we can come across the output easily. So for those, we do have the normal form of a Boolean expression. So in short, if I am just want to ask what exactly we mean by a normal form. So a normal form is the simplified expression of a compound proposition. Compound proposition, we can call it as a Boolean expression too. In the last session, we also discussed about that what we mean by a compound proposition and what or how exactly it can be constructed by using the different connectives. Normal form is the simplified version of those compound Boolean expressions. Now the question arises why we need those simplified expression. The thing is that if like in real life, when we are talking about a compound proposition, it do have n number of proposition and we are combining them. So if we are simplifying it in a detailed manner, it will take a lot of time as well as lot of better to say lot of computational time and computational cost. So to reduce that, what we can do, we can write the given Boolean expression in a simplified form that we called as a normal form. Okay. So normal form refers to the standard representation of a compound statement or compound proposition. Yes, in a specific manner. Moreover, when we rephase the compound proposition into a normal form, it's not like we are changing the nature of that compound proposition. What we are only doing, we are doing the adjustment with the compound proposition so that it will looks like in a specific manner. When talking about normal form, we do have two kind of normal form. One is known as the disjunctive normal form. We also call it as DNF or SOP. SOP, that means the sum of product. Disjunctive normal form, also called as the sum of the products. In logic gate, when I'm talking about the sum means that is the plus. The OR gate is used to write these things. So in place of OR gate in the discussion of this session, we are using the notation plus. So P or Q can also be written as P plus Q. Okay, so this is what we call as a sum. Then the product. The product means what? The AND gate is denoted by using the sign product, that is the dot. So we can, in place of writing P and Q, we can write it as P dot Q. So a form where we do have the sum of the different product is called as the disjunctive normal form or DNF. Okay, so we are supposed to connect the AND terms by using the OR connectives. In short, this is what we can say for DNF or disjunctive normal form. So it is sum of product. If suppose that we do have two variables, so I can write it as P dot Q plus P complement dot Q. This is one of the example of sum of product, doing sum of the product term. Okay, it can also be written as PQ plus Q complement. So this is product, yes, P dot Q. It is product, yes, we can write into one. So sum of product. Understood? So this is how a DNF can be represented. Why it is essential? We'll take one example on it. Before that, the second form that we do have is known as CNF. CNF or conjunctive normal form, also called as the product of sum. In DNF, what we are doing, we are writing sum of the product. In CNF, what we are writing, sum of product of sums. So one of the sum is what? P plus Q. This is one of the sum. And one more sum I can write it as P complement plus Q. And if I do the product of these two, this is one of the CNF, where every term is in terms of some addition, some OR connective, and combinedly all of them are connected by AND. All of them are connected by AND connective. One of the example of CNF. We can write few more or many more example. Let us write one more example for DNF having three inputs PQR. So let us say one input is PQR, then plus PQR complement, then PQ complement R. So these are the product term, and if I add them, I will get a DNF, disjunctive normal form. Similarly, if you want to write CNF for three variable, it may be P plus Q plus R, then P complement plus Q plus R. So these are the sum, and they are product to each other or multiplied with each other, that is using the AND connective between them. So CNF. Understood? Now the question is what? How it can help to reduce the computation time, computation cost for a compound Boolean expression. Now, just recall the truth table for AND and OR connective. What is the truth table for AND connective? It says that when all the inputs are T, then the final inputs are T. If any of them is false, the final output is false. So now suppose that as this is one of the AND connective. So like what we can say, OR is connected by AND. So the truth value for a CNF will be T. The truth value for a CNF will be T if all the individual sums is T. If all these sums are T. So this looks like T and T. So we'll say it is T. Understood? Now, one more thing is what? If suppose that we do have n number of these sums, and we comes to know at the initial phase of the calculation that one of the factor is f. So suppose that if first is f, now it does not matter what is the truth value for the other sums, the final output in case of AND connective will always comes out as false, even though we didn't know the rest of the truth value for those sums. So this is the advantage for a CNF. On the other place, if I do have a compound proposition which looks like P implies Q, and let us say and Q implies P, so it is not in any of the standard form. It is not in any of the standard form. So if I am interested to find the truth value for this proposition, or better to say the compound proposition, I am supposed to solve it completely. But on the same side, if it is in some CNF, then its truth value can easily identify by knowing if at least one of them is F, the final truth value will be F. If all of them is T, the truth value is T. Then this is how we can do it. Now, if I am talking about DNF, the disjunctive normal form, if I am talking about DNF or disjunctive normal form, so in disjunctive normal form, what is there? Every term is product and they are connected by OR connective. They are connected by OR connective. Now, what is the truth value for OR connective? The truth table. In OR connective, what it is says, it will comes out as T if at least one of them is T. The OR connective gives you F only when all the inputs are F. Otherwise, it will gives you T. Now, in place of simplifying this complete expression, if somehow I comes to know the truth value of the first term is T. Now, it does not matter what is the truth value for the other term. We can directly say the truth value for that compound proposition is T. I hope you understand the advantage if a Boolean expression is in the standard normal form, whether it is CNF or DNF, we can easily identify or easily obtain the truth value of that compound propositions. Okay, now moving ahead. So this is some detailed about a CNF or DNF, disjunctive normal form and conjunctive normal form. If I want to quote the definition, what exactly a DNF looks like, so it is a logical expression which is represented as a sum of the multiple products term, sum of the multiple product term, or of the end terms, or of the end terms. Here, each of the product either consists one of the variable or all the variable. For example, if I am writing a DNF which can be written as PQ plus Q complement, it may be in two variable, it may be in two variables. So this is having both the variable, this is not. Still, it is a DNF. Pay attention to this. This can be written like this. So in DNF, it's not necessary that every variable should present in every term. You can use this knowledge when we'll talk about the principal CNF and principal DNF term. Okay, so if I take one example, just see, this is one of the Boolean expression which is A and B union C. If I use the distributive law, it will looks like A and B union A and C. I can write it as A and B means A dot B, or means plus, and means dots. So A dot C. So now over here you can see this is a product, yes. This is a product, yes. And they are sum. It is sum of the product, SOP. So one of the example of disjunctive normal form or DNF. Over here you can see there are three variable, and it's not like every product is having all the three variable. It's not mandatory in DNF that every product should have all the variable. In the same manner, if I am talking about conjunctive normal form, so in CNF, a logical expression is represented as the product of multiple sum, product of multiple sum, and of or terms. Okay. Now, here each sum of the term, as in DNF, may have one variable or their complement, or may left with some of the other variables. The overall expression for a CNF is the product of those sum term. For example, as we did take the last one, so if I am over here, which is A or B and C, applying the distributive law, it looks like this. So this is what? A or B. So or means plus, and means dot, A or C. So this is one of the sum, this is one of the sum, and in multiply, what we called it as product of sum or CNF, conjunctive normal form. Now, if someone asking you what is the truth value for this compound proposition and the truth value of this compound proposition, yes, it's quite obvious that it will take less time to let you know that whether the compound proposition is true or false when I compare to this one. Because for this, you are supposed to make a complete truth table. For this, if you know the input for any of them is T. Suppose this is T. No need to check this one. The compound proposition comes out as T. Understood? So this is how we can understand a CNF, product of sum, and a DNF, the sum of products. Now moving on, the extension of CNF and DNF is what? Principal CNF and principal DNF. Principal disjunctive normal form and principal conjunctive normal form. So the major difference between a PDNF and a DNF, or I can say PCNF and a CNF is what? In PDNF, in every term, every variable must be there, either in the original form or in its complemented form, In DNF, it's not mandatory that every variable should be there. So now, if you see, A compound proposition which consists of only conjunction of min term is called PDNF. Now there's a one new term which comes over here called as a min term. Okay, so in PCNF and PDNF, we maximally talk about min term and max term. Min term and max term. So if we do have two variables, let us say P and Q, then the min term for P and Q are is listed as all the combinations of the variable, either variable or their complement. So what are the four cases for two variable? Either they may be in the product without complement, first complement, second as it is, first as it is, second complement, or both of them complement. So in case of two variable, we do have four min term. This can be considered same as the input of a two proposition truth table. Remember two proposition truth table? If we do have two proposition which is P and Q, what is the possible inputs? 2 times T, 2 times F, 1 times T, 1 times F. So T means what? The original variable. So PQ. F means the complement. So P is as it is, Q is F. So Q complement. Then FT, so P complement Q, and FF, P complement Q. So this we called as a min term, the product of the possible input for a compound proposition. On the same side, we do have max term. Now, what is max term? In place of dot, we do have the or connective, that is plus. So these are the or these are the max term in case of two variable. These are the max term in case of two variable. So if we do have two variable, how many min term? 2 power n. If we have two variable, how many max term? 2 power 2, that is 4. If three propositions are there, that means the compound proposition is having three variables. In that case, 2 power 3, that is, we do have, in that case, we will have total 8 min term and total 8 max term. Understood? We called a DNF as a PDNF if every term is a min term. If every term is a min term, we called a CNF as a principal CNF if every term is a max term. If every term is a max term. For example, if I can have one standard normal form in two variable, which is PQ plus P complement. So can I say it is DNF? Yes, this is a product, and this is sum. So we can say it is DNF or disjunctive normal form. But can I say it is PDNF? Is it principal disjunctive normal form? So the answer is no. Why? Because this term is having both the variable PQ, but it is not. When I am saying both the variable, either the variable in its normal form means original form, or it's in complemented form. So this is DNF but not PDNF. Understood? Now if I take one more, so PQ plus P complement Q. Is it DNF? Yes, it is DNF. Product of sum of product. Is it PCNF, PDNF? Can I say it is principal disjunctive normal form? So answer is yes, because both the term is having both the variable either in the original or in its complemented form. Either in the original or in its complemented form. Every PDNF is DNF because principal disjunctive normal form is more than only DNF. What is more than? More means what? It not only having product, but it is having the min term. So every term should be min term, and if it is in that case it is the sum, we called it as the PDNF. The same for PCNF. If I take for two variable as P plus Q and this P. So can I say it is PCNF? This is sum. This can also be written as sum, P plus 0. Yes, it is sum in product. So it is CNF, no problem. But can I say it is PCNF? The answer is no. Why no? Because this is a max term, but this is not a max term. This is not having variable q. So I can write it as pq complement. One another example, p complement plus q. Now over here you can say both of them are the max term. Both of them are the max term and contains here both of them are the max term. Both of them are the max term if I'm talking about these two. So, and also it is the product of sum. So yes, this is PCNF. I hope you understand the difference between a CNF DNF and PCNF and PDNF, and also what we mean by a min term and max term. What we mean by a min term or a max term. A PDNF which consists of all the min term is called as the complete DNF. Okay, a PDNF which consists of all the min term called as the complete complete disjunctive normal form. A CNF or PCNF which consists of all the max term is called as the complete conjunctive normal form. And like for a compound proposition, we can have different DNF or PDNF. But when I'm talking about complete CNF and complete DNF, it will always be unique. So if I want to write CDNF for two variable, that means it should have all the min terms with it. It should have all the min terms with it. We will use this concept when we talk about the conversion from CNF to DNF and DNF to CNF. So this is called as conjunctive disjunctive normal form in two variables, okay, P and Q only. So having all the min term. In the same manner, if in place of all the min term, we are writing all the max term, we called it as CCNF. So in CCNF for two variable, it will be P plus Q, then P complement plus Q, then P plus Q complement, and plus P, then P complement plus Q complement. So product of all the max term is CCNF, complete conjunctive normal form. Okay, so let us take some example that how exactly we can use, we can obtain PCNF and PDNF for a given compound proposition. So if a compound proposition is given, we can find the PCNF or PDNF corresponding to that compound proposition by using two ways. One, we can use the truth table, and the second, we can use algebra of proposition. That means laws of proposition. We do have certain laws based on these logics. So we can use those logic and convert the given Boolean expression in the standard normal expression. Okay, so now let us take one or two examples that how exactly we can do it. So this is first example, which is saying we are supposed to find a PCNF and PDNF for this Boolean expression, which is negation P or Q and biconditional P and Q. Now, if I am interested to find the truth value for this Boolean expression, so in that case, I am supposed to find its truth table, then do all the computation, and then we can say in what case is it true, in what case it will be false. But in place of this Boolean expression given in the raw form, if it is in the normal form, then it's not like I should solve each and every term. If it is in PCNF or PDNF, then I can evaluate only one of the term, and on the basis of that term, we can easily find the truth value of that or for that Boolean expression. Understood? Now let us take this example. I am going to solve it by using the truth table. Let us see how. So first we'll make the truth table for this compound proposition. How many variables are there? Two variables are there. So the truth table will have total 4 inputs combinations. So 2 times t, 2 times f, 1 times t, 1 times f, 1 t, then 1 f. If 3 variable is there, total will comes out as 8, 4, 4, 2, 2, 1, 1. Now what I needed in this truth table, I needed P or Q column. I needed negation of P or Q. Then I needed P and Q. I needed P and Q. And finally, in the last column, I can make this is as P or Q, then biconditional P and Q. This is the your Boolean expression. Hai na? This is the your Boolean expression, the compound proposition. Now, as discussed in the last session, how to write the truth table for a compound proposition, we can use that concept. So the first one is P or Q. Remember for or connective, at least one T, the output is T. So the first one is T, it is also T, it is also T, both of them is F, it is F. Now the negation of P or Q. So the negation of this is this one T, the negation of this is F, the negation of T is F, the negation of T is F, F is T. Now I needed P and Q. So for AND connective, it will be T if all the inputs are T. So P and Q, for this, both of them is T, so it will be T. They are not of the same nature, so it will be F. Not of the same nature, so it will be F. Not of the all of them F, so it will F. So I get it as negation P or Q, and P and Q. Now we are supposed to merge these two by biconditional. So the truth table for biconditional says if the nature of all the inputs is of the same, that means either all T or F, the final output for biconditional comes out as T. So F and F, they are not same, so it will be F. F, they are same, so it will be T. F, they are same, it will be T. T and F not same, so it will be F. So this is the final truth table for the given compound proposition. Okay, this is the final truth table for the given compound proposition. In place of TF, we can use 1, 0 also. Okay, so F means 0 and T means 1. So it's your convenience that you are using TF or you are using 1, 0. Now, how to write principal DNF and then how to write principal CNF. Once the truth table done, then we can easily write PCNF and PDNF for the given Boolean expression. Okay, now let us see. First, I am going to write the principal DNF, principal disjunctive normal form. Now, principal DNF, when we are writing from the truth table, we will focus on the final column whose truth value, in the final column, inputs whose truth value is 1 or T. So we do have two ones. And these two ones comes on the basis of these two inputs. The second one comes on TF. The third one comes on FT. Now, T means the original variable, F means the complement of the variable. T means original, F means its complement. And we are writing PDNF, so we'll write the minterm of that. So, what will be the minterm for this? Original variable is P and Q is having F, so Q complement. So, this will be P dot Q complement. I hope there is no problem with it. P dot Q complement taking output as 1 and corresponding to that output, we are writing the minterm. Now, this is also the second minterm. So, this is F. F means complement. T means as it is. So, these are the two minterm which gives output as 1. We are writing PDNF. So, when we add them, we use the principal disjunctive normal form for this Boolean expression. Principal disjunctive normal form for this Boolean expression. Once again summarizing, in PDNF, focus on output 1 and write the minterm for those output 1 inputs. If it is T, write original variable. If it is f, write the complement of that variable. Talking about PCNF, so in PCNF, in place of 1, we are supposed to focus on zeros. In PCNF, in place of 1, we are supposed to focus on zeros. So how many zeros are there? This is 0 and this is 0. What is the input for this? The first one is the input for this and last one input for the last one. Now, over when we are writing PCNF, we are supposed to negate the inputs of. So this is TT. What will be the negation for this? F and F. Very important point when writing PCNF. Taking output 0 comes to input and reverse your input. So this is FF. So F means P complement. This F means Q complement. And write the max term. Max term means the sum. So this is the max term for the first one, which is earlier TT, but due to we are writing PCNF, we are supposed to reverse it. This is FF. So when I reverse it, it will comes out as TT. T means the original variable. So P plus Q. So this is PCNF for this Boolean expression. That means the Boolean expression which is given as this can be written, or we can say is equivalent to one of these or both of these. We can write this like this, or we can write which is also equivalent to this. In the last session, we talked about the logical equivalents. So the truth value for both of them comes out as same, hence they are logically equivalent. So now in place of the given information, if we do have this or this, it's quite easy to find out the truth value of the given compound proposition. I hope you understand this concept. So this is one more example. Try to think on it. I hope you understand it. So now let us close this session